On behalf of the whole group, we want to thank Adeline for the amazing job that she has done, along with her team. I really want to thank Omar and Rachel, who have been incredibly patient with me, especially waiting for all the papers and so on that I had to give them, all the documents. And I'm grateful just for the opportunity to be here to represent the Refsum community and be here with friends and families who mean a great deal to me. So for our work group agenda today, I'm Joe Hacia. I'm at the University of Southern California. I'll give a brief introduction and heat map overview. And my two partners in crime are Kristie DeMarco, the president and founder of the Global DARE Foundation, who will be speaking with a patient advocacy perspective, and Florian Eichler, who will be talking about natural history studies and model systems. So our work group roster was quite amazing. They're actually all members of the board, medical and scientific advisory board of the Global DARE Foundation. And for anybody online or who's actually attending here today who would be interested in joining our work group or potentially board in the future, we'd really welcome you. We love the fact that it's an international community with people from Amsterdam and the UK playing major roles, in addition to a fledgling group of researchers here in the United States. So as an overview, adult Refsum disease is an ultra-rare autosomal recessive disorder, and it's primarily caused by biallelic loss-of-function variants in the phytanol-CoA hydroxylase gene. And as a result, there's a compared catabolism of a dietary branch-chain fatty acid called phytanic acid. And the accepted hypothesis in the field is that the accumulation of toxic stores of phytanic acid in various tissues is causally responsible for disease. And as Adeline mentioned, this afternoon we're talking about adult onset disorders. And from the literature, you can see reports of people ranging from 6 years of age to 60 years of age first presenting with adult Refsum disease. But in general, on average, the patients are presenting in their 20s and 30s, primarily with retinitis pigmentosa or loss of night vision. And then there's concomitant with that loss of, in many cases, sensory neural hearing loss, as well as anosmia. You're seeing a late onset polyneuropathy and ataxia. And if the disease is left untreated, it can be fatal due to the onset of cardiac arrhythmias. Phytanic acid itself is an interesting molecule. It's derived from the catabolism of chlorophyll in ruminant animals such as cows, as well as zooplankton and krill. So humans cannot produce appreciable amounts of phytanic acid by chlorophyll catabolism. And in fact, humans can only obtain phytanic acid from the marine or terrestrial food chain. So we have our friend here, chlorophyll in the upper right, and you'll see the side chain called phytol, and that could be liberated from the chlorophyll molecule by gut fermentation in microbes in ruminant animals in their stomachs, as well as digestion of phytoplankton by zooplankton and krill. As a result of liberating phytol, it's known that it gets oxidized to phytanic acid in all land mammals surveyed to date, as well as in marine organisms. And so phytanic acid is the culprit here. And that's humans really just get this from the diet. So they do not endogenously produce phytanic acid. So phytanic acid itself provides no known health benefit to humans. So the way I like to think of it as the 800-pound hippogriff in the room is, why not just eliminate phytanic acid from the diet and everybody can go home early and catch their planes? So another guest in our advisory board is Professor McGonigal, who you might recall from the Hogwarts School of Medicine. For those who have taken your hippogrific oath yourself, who have went to Hogwarts. And she would say, why not just eliminate it, get a simple spell, change them to vegetables, and all is well and done. And so she was a great deal of fun on our advisory panel. She recommended us read this book, Fantastic Beasts and Where to Find Them. And this inspired our work group to think of a cookbook called Phytanic Feasts and How to Avoid Them. And you're seeing our dear friend Ann Mosier is doing the bulk of the work of profiling phytanic acids in foods. So it's been wonderful continuing to work with her. On a more serious note, through the history of adult Refsum disease research, for many decades, the diet has been the center of the therapy. But we do know now that the effect of dietary intervention is not completely understood. There is good evidence that it slows the progression of vision and hearing loss, and there's also good evidence that it can be able to stave off these cardiac arrhythmias that can be fatal. But the other aspects of disease, it's a little bit more murky simply because it is an ultra-rare disease, which very limited numbers of cases have been reported. And in addition, and it's really important, that phytanic acid stores in adipose can be mobilized in response to stress, such as fasting, illness, and exercise. And Kristie DeMarco can tell you about her own personal story. I just was talking to Mark Englund at the break before, and he actually was telling me about some of the patients themselves who underwent surgery and actually died due to the fact that they had of a cardiac arrhythmia due to the fact that during the fasting phase they just accumulated so much phytanic acid that's stored in the adipose for years in their life. So just the diet itself is not the cure-all. So in terms of research challenges and successes, the Global DARE Foundation is spearheading patient registry efforts. Kristie is a force in nature, as are all the other patient advocates that are here that really do inspire me and everyone else in this room. We do have a widely accepted basic underlying mechanism of disease, which is phytanic acid toxicity, but therein lies the rub that we don't really understand completely why phytanic acid is toxic. We know that it probably has something to do with mitochondrial dysfunction, but even that is not fully elucidated, so there's a lot of work to be done. There's a Phy-H-Null mouse model exists that Florian will speak about that was developed in the Netherlands, and it reflects neurological aspects of the disease, but it's still a work in progress. So there's still a lot of research to be done, and he'll describe some of that in his talk. ARD itself is a multisystemic disease where the state of clinical outcomes measured vary according to the compartment of interest in this stage of disease progression. So it's a different story if we're talking about vision loss versus the peripheral neuropathy versus the cardiac arrhythmias. So we have to keep that in mind. And right now, no clinical trials have been conducted or are planned at this time. Now, for the clinical challenges and successes, we do know that plasma phytanic acid levels are a robust biomarker of disease and provide the theoretical basis for newborn screening. So this is where you get into the world of anecdotal stories, like Kristie has told me that she knows of a family where they have a 6-day-old infant who actually was screened and tested for phytanic acid levels in their blood, and it turns out that it was indeed elevated. And there's going to be some efforts now to try to do some retrospective studies on blood spots. The general thought or gestalt is that the phytanic acid levels may not be elevated on day 1 after birth, but in states where they have a second screening at the second week of life, there might actually be an opportunity to catch people with elevated phytanic acid levels. So that's all in theory, but it's something to think about. So the phenotypic severity depends on levels of residual gene activity and potentially the causal gene. We talked about this Phy-H gene, this phynyl-CoA hydroxylase. That's 90% of the cases. About 10% of the cases, there's a defect in this PEX7 gene. For those who are into pexology of the world of peroxisome biogenesis disorders, PEX7 is actually the transporter that will bind to Phy-H, that enzyme, and transport it into the peroxisome where it's involved in the magic of alpha oxidation to break down phytanic acid. All right. So there's a small community of experienced, dedicated professionals across the world that focus on ARD medical research. So we do have the best and brightest on the team, which is amazing, and just an amazing collegial group as well to have shared expertise in all areas. And so it's been a joy working with them. And right now, the research community is in the earliest stages of planning treatment guidelines, but that's something where we really want to go, and you'll hear that from both Kristie and Florian. And diet and plasmapheresis are well established as having some benefit for patients, but are not curative and may not be feasible for everyone. So when we look at this Refsum disease heat map overview, which with my impaired vision I put in slightly larger font, you can see a little bit that we were pretty optimistic that in general, for the first time that we presented, we see some greens over here, which include the preclinical scientific development, and we're thinking in that regard that we have pretty good biochemical biomarkers of disease, so we can actually use them to diagnose and potentially look for treatment interventions to see if we can lower phytanic acid levels in tissues in the patients. In terms of advocacy, where Global DARE has just started, but it's really had a major impact on our field. And for therapeutic development, unfortunately, even though we do have something robust in the phytanic acid limited diet, we do not have any targeted therapies right now that are going to be aimed at lowering phytanic acid burden in various tissues in the body. But there are a number of ways you can envision that, from everything from gene therapy to mRNA replacement therapy and so on. So there's a lot of room for optimism and growth. So at this point, I'll pass the torch to my colleague here, Kristie DeMarco.
Thanks, Joe. As you can see, I don't have any PhD or medical degree next to my name, but I have gotten a crash course in Refsum. I was diagnosed 3 years ago. And what I think, bring to this work group, in addition to the folks around the table, is I've been in banking for 24 years, getting multi-million-dollar projects executed. So I know how to get stuff done. And so being able to organize the team and help drive things forward, and as Florian and Joe will attest to, I'm the squeaky wheel that constantly wants the grease. But it's a pleasure being here. I'm really excited to have Refsum talked about at this conference. So let me put the first page here. So I started Global DARE Foundation about 3.5 years ago after I received my diagnosis. It took me a couple years to get a diagnosis. I think I got a couple of diagnoses before I actually got my Refsum diagnosis. They actually thought I had MS. I was presented with, neuropathy and some vision loss, and they thought I had MS. Some spots on the brain, I think, is what they were telling me, but that obviously wasn't it. It wasn't until I got genetic testing that I actually found out that I had Refsum's disease. What I found out was that there was some really great research done in the past, but no one was really doing anything. It's good 15 years since anyone has really picked up the torch for Refsum and done any research or advancements. And so, I found the only way you really can get stuff done in this field is to start a patient group. And so that's what I did with a couple of other patients, as well as some family members, whoever I could kind of pull in to get the work done. So we started Global DARE Foundation, and the mission is simple, right? We want to improve the quality of life of patients, and so that's what we're doing. We started out with connecting with about 26 patients, and after 3 years, we've connected with 60. So every year we're growing a little bit more. As Joe said, it's so 1 in a million that from what we know. But I think there's a lot of, as I'll show you in some of our patient registry metrics, it takes a long time to get a diagnosis. So I think there's a lot of people out there that we haven't connected with yet. So some of the successes, Joe said we started a patient registry. So in my professional career, I know that data drives insights and decisions. And so when I was researching how do you get research started, they're like, you got to get a patient registry. I actually tried to get a patient registry started before I started a foundation. I contacted the ULF. I actually think I contacted CHOP about their leukodystrophy registry. And they're like, no, you really need a patient organization before you can start a registry. It's a lot of work. I'm like, okay, well, I guess I'll go for the patient organization. So today, I said we've connected with 60 patients. We have about 50% of those in the registry. So that's, I want everyone in the registry, but I hear 50% is a pretty good percentage for just getting started a couple of years ago. And it really was, our goal wasn't clinical trial readiness, at this point, right? All I really wanted to do was bring our patient population into a central repository and start to learn some things about the disease. We also had patient input on the questions because there's a couple of things that aren't noted in literature or understood from a clinical perspective, and they wanted to understand are these things part of the disease? Is it common across patients? And so even if it's just to give us some insights on what areas of research we should pursue. So it's been really great. I'm going to show you a little bit of the metrics because I'm a data geek myself. So I like to do a little bit of analysis, and I'll show you what that looks like. Food testing program. Has anyone seen photanic acid on a food label? No. In the past, there was about 150 foods tested, which is not that many, right? And so that is the food testing that was used to actually inform the initial diet. So you can only imagine a lot of assumptions went into putting together that diet. As an example, they tested nuts, one nut, and that was high in photanic acid, so all nuts were excluded. Well, that for patients, that's a big impact. I mean, you all know food is part of our daily, regimen, right? It impacts us in lots of ways. And so one of the really low-hanging fruit that we thought was really great to get people engaged and be able to make an impact for patients was to test more foods. And so we coursed Ann Moser to help us out in testing some foods. And we actually understand there's an additional marker to test for biochemically as well for phytyl fatty esters, which can be broken down into photanic acid as well. And so our first year we tested 60 foods. We're testing another 40 this year, and it's really made a difference to inform the guidance. Now we have a really great traffic light system of go, you can eat whatever you want, yellow, a little bit of caution, and red, don't eat any of that. And so it's made a big impact to patients and gotten patients engaged, right? So anytime you can get people interested in what you're doing, the more engagement you can get. I'll let, Florian's going to talk a little bit about the Center of Excellence and the Refsum mouse model, but just to touch a little bit on it from a patient perspective, Florian and I think it's about a year ago, him and I kind of brainstormed the idea of there was this Refsum Center of Excellence in the UK, not really accessible for those individuals in the US. And so how could we create something like that in the US? And me being the squeaky wheel, talked to Florian and said, hey, could we bring our Center of Excellence together in Boston at Mass General and Mass Eye and Ear. We've got a multidisciplinary team that's come together. And to me, that makes such a difference to patients. I know even just myself being able to go for a couple of days and see all of the specialists and actually have them talking to one another, and understanding the full picture of the patient just makes a tremendous difference for us. And also, that center is well connected with our Refsum Center of Excellence in London, so they can do comparative case studies and things of that nature and learn from one another. And the Refsum mouse model, there was a lot of great work done in the past, and like I said, not much has been done in the last 15 or so years, but there was a mouse model created, and that's being picked up. It's been brought to Kennedy Krieger, and we're starting we just had some discussions last week, around some translational studies that we're going to get started, so really excited about that progress. Just to give you a little bit of the data analysis I've done on the patient registry data. So we have about 17 countries that we know patients, we are connected with patients, but 10 countries are represented in our registry. Got 33 patients so far. Most of them, as you can see, 74% are generally diagnosed through genetic testing, not through clinical diagnosis. The interesting thing is pain isn't necessarily a top symptom as far as Refsum's concerned, but 67% of our patients experience daily pain. And I know from personal experience that's exhausting. So is that something that we can do for patients? And then what was really interesting as well is that the clinic in London, who's really been driving the diet, it looks to manage people down to a level of 200 micromoles per liter of photanic acid in their blood. But as you can see from the middle chart, on average, 50% of the individuals have greater than that over a 3-year period. So why is that? Is that, they're also reporting 96% good compliance, strict compliance to the diet, or are there other factors at play? As Joe said, we store photanic acid in our cells and our fats and nerves over the course of so many years. Are people not getting good advice when it comes to weight loss or exercise or fasting for surgeries. I've definitely heard anecdotal evidence from patients that they're not given the right advice when it comes to those things. So is that a factor, or is there something else? But something to look into further as far as the research goes. We also, we don't have clinical guidelines, so, one of the things was to really understand how are people being treated today as well, like how often are they, seeing certain specialists, how often are they having certain tests, how often even do they have their photanic acid level tests, which I thought was really surprising that 44% only have it done on a yearly basis when that's the only way we really have to manage our diet. That would be like a diabetic only getting their A1C once a year or even taking their glucose once a year. So really interesting information, and we'll just continue to collect as time goes on. So for some challenges for quality of life of patients, so late diagnosis is significant. If we could improve the shorten the length of time to diagnosis, that would be significant for patients, because the diet does make an impact, right? It does slow vision, it does slow hearing loss. It might not prevent it from happening, but if I could keep my vision for 10, 20 years longer, I'd want to do it, right? So the sooner we could get someone on the diet, the person that Joe mentioned that got his diagnosis at six days, he has really no symptoms, and he's 26 or 27 now. So where his sister, he was diagnosed because his sister was diagnosed at 10, she has many more of the symptoms. So early diagnosis makes a difference. And so the more we can educate, and, often they're diagnosed with a retinitis pigmentosa diagnosis first. If we can get people diagnosed at that point, at least, a newborn screening would be ideal, but obviously Joe mentioned we have maybe a potential couple of complications with that. But even if we could educate ophthalmologists to be looking and screening for this, and if folks aren't interested in doing a genetic panel, at least do a photanic acid level, because that's a good indication of the disease. Lack of clinical knowledge, we're hoping to help solve that with the centers of excellence, but we have no clinical guidelines and even any consensus level guidelines, and that's a challenge for patients, right? Because they're getting different care wherever they go. And think of the developing countries; there is no guidelines out there to direct physicians on how to care for patients, and so that obviously provides a lesser quality of life. Photanic acid accumulation. So, we know that it accumulates over time, and the impact on patients is significant, right? Because just think about your everyday. You're often trained as just a human. Fat burning is good for you. Well, fat burning isn't good for me. I've got to minimize my fat burning. I've got to minimize. I've got to be really careful when I exercise. I have to be really careful when I go for surgery, or if I'm sick, I have to be very careful. That's a huge impact to patients. So, what can we learn about the toxicity of photanic acid and ways that we could potentially help patients from that perspective? And as Joe said, the diet has limitations. It might slow things, but it doesn't prevent things. So how can we make steps towards better therapies in the future? So that's it for me. I'm going to hand it over to Florian.
Great. Thanks, Kristie. Thanks, Joe. And I'm delighted actually to have learned so much from Kristie about this, and hope to bring all the resources we have in Boston to this disease. It's very nice actually to have a series of adult leukodystrophies here in this last session, because I see a lot of similarities in thinking about CTX and ADLD in this context. Really makes you think of similarities. And as Kristie said, part of the goal of organizing and creating a center of excellence in Boston is to really build on what has happened in the UK for many decades, and learn from guys in St. Thomas Hospital. And we're very fortunate to have close relations with Tony Verbitsky, Radha Ramachandran, who've taught us so much together with their dietitians there. So really build centralized expertise in Refsum disease, using that knowledge and raising the profile of Refsum disease for earlier diagnosis. building community amongst people with Refsum disease in the U.S. and their caregivers. I will say that most of the patients who come to my clinic come because of Kristie, and Kristie is really the driving force here, who is bringing so much of the community together and having patients talk to each other, inform themselves, and bring knowledge to us physicians is really making all the difference in terms of care and management. Nevertheless, we have the opportunity to bring several specialists together and coordinate clinical appointments across disciplines, improve standard of care. We have ophthalmology and ENT at Mass Eye right next door, a wonderful neuromuscular specialist, Dr. Sejadi, physiatry, and then metabolic specialists who are really keeping an eye on phytanic acid levels together with dietitian Dominica Nichols. So what we're really trying to do here is bring clinical care and research together as we are seeing patients and we're gathering knowledge. We're also establishing an IRB to collect data, collect information, and clearly we're still at the very beginnings of doing this. But by also seeing patients, I'm always keenly aware of identifying unmet need and knowledge gaps. The things that we might be reading about adult Refsum disease might not be the things that are ailing patients, and the spectrum of this disease might be far larger than we're currently aware of. So collaborate broadly and internationally, and I think it's really nice to have the group in the UK that are also helping us along. So one of the things I like to do when I encounter a new disease is to do an inventory, and often starts with the literature, what has been known to date, what has been published. And although this disease has been known about for a long time, there's really been a very sparse literature, I'd say, and really a stuttering of papers over the decades. And I had a very talented high school student, Christopher Eaton, who joined and was very enthusiastic about performing a literature review, and had identified 247 patients across 67 papers. And similar to the graphics that Kristie showed, the most prominent symptoms were retinitis pigmentosa in close to 70% of patients, ataxia and peripheral neuropathy second and third, and then hearing loss in other organs affected. And along the themes of Joe introducing the Hogwarts enthusiasm, I decided to put in this Hogwarts hat. So this is all coming from Joe, so I also credit him for all the nice slides here. Research challenges here are clearly along understanding model systems of the disease. There is a PHYH, a null mouse that was developed by Sasha Fernandez in Amsterdam and then reestablished at Johns Hopkins. We were very lucky to have Joe Scafidi now working on this and bringing all his talents to this. And this is a mouse that is with phytol supplementation showing a worsening of phenotype. You can see that in a dose-dependent way, there is an increase in phytanic acid levels across highest in liver, and contributing to a worsening of liver disease in this mouse, as well as ataxia and the peripheral neuropathy also worsening. There is also a loss of Purkinje cell neurons in this mouse as well. Importantly, there is no sign of retinitis or eye abnormalities, and so there will be things that this mouse will be helpful for. There are other things that there will be limitations around. So we really have to understand and how to optimize dietary exposure, to study also this mobilization of phytanic acid out of adipose tissues. Is this going to be the right model in a mouse to study this? But it is clearly of central concern to patients, and conducting in-depth phenotyping of the mice relevant to the human context. Research challenges extend beyond to testing therapeutic hypotheses. I think we really are still at the beginning of understanding the basis for phytanic acid toxicity in mouse and cellular models. Similar to maybe some of the other genes that we've heard about in the last few sessions, this might very well be less a disease-causing gene as a susceptibility gene where you have a susceptibility, but here with more pronounced metabolic component, and what are the aggravating factors, what are the modifiers that are contributing here. So metabolic stressors and liberating phytanic acid stores in adipose tissue strikes me as a low-hanging fruit here. If we can understand that, we can understand physiology and really run very short-term experiments and understand how to maybe bring about successful trials in shorter periods than otherwise in chronic adult onset diseases. We can evaluate genetic therapies to enhance phytanic acid oxidation in the liver. There are some ongoing projects in gene augmentation, mRNA replacement to reduce phytanic acid burden across the body. But risk-benefit ratio might be different in this disorder, and gene therapy may not be the first thing to pursue. So developing alternative approaches like small molecule therapies to enhance minor alternative alpha omega oxidation pathways could be helpful. I think in all cases we want to understand the pathophysiology behind this. Are we targeting certain specific cells, or are we thinking about non-cell autonomous pathophysiology? And having a mouse model to do this certainly is a first important step, but we might need other model systems along the way. So many challenges ahead, but it's great to have Kristie and Joe and many others here that I've shown along for the ride. Thank you.
Joe, thank you for your thematic addition to the slides. Those were fun. Questions from the audience?
Thank you. That was fabulous. Kristie, I have a question for you. I am such a fan of everything you have done in such a short period of time. You're taking us all by storm and are such an inspiration. That's not a question, but that's just a statement. My question for you is, you have gathered so much important information on how patients are managing their symptoms and what's really affecting them. But oftentimes that information is siloed away from doctors and the advice doctors are given. So how do you propose we can help to integrate the patient experience into how we counsel families going forward?
That's a good question. So you're thinking about the patient registry data we're collecting, and how does it help inform the clinicians and things like that? That is something that I've been thinking about, like how do I actually do something with the data that we're collecting? And one of the things that I've talked about with Joe is looking at the ability to publish that data in some way. What level of scrutiny is the data required to be under? It is IRB approved, through Sanford Cords. So I feel like we should be able to use the data to publish it. I think it would be great to be able to do that. And we are looking at, there's also. I always say that there's just so much to do, trying to find, like, when do we do it? Do we wait for a certain period of time? We've been collecting it for a couple of years now. Is a certain number of patients we should wait for. But I agree we should be using the data in some way to help inform clinicians and others, and potentially look at areas of research, as I was saying. So thank you, Linda.
I have a question and a comment too. I think that some of the work groups are thinking about sort of standard of care recommendations and sort of consensus statements. And I guess, would it be possible for your work group to think about sort of building on the patient reported information to sort of make consensus care recommendations, sort of like translating effectively those patient impressions into something that into doctor speak, so that doctors know what to measure, when to measure, based on expert opinion, given the lack of probably more global evidence.
So I mean, that was one of the reasons why we put some of those questions in the registry, right? Was to understand, how are patients being treated today, and is that, providing good outcomes? The hard part I'm not sure is whether we know that the care that they're getting is getting good outcomes. Like I found it was very interesting that, as I mentioned in my talk, that photanic acid level is only tested once a year in 44% of the patients, which seems rather, I get mine done monthly, which, maybe that's more. I'm a data geek, so maybe, I'm interested in finding out. But I feel like if you're going to exercise or you're going to look to lose weight, like you would want to track your levels more often to see whether spikes in those levels are actually causing symptoms. So I don't know whether it would at least let us know how people are being cared for and whether that would be insightful into the potential standards of care. We are working on those standards of care in our the UK clinic. They've got the biggest cohort of patients. It's 20 or more patients that they care for, and so I think they've got a standard of care. They just have never published one, And so we're kind of pushing on publishing that, and even if it's just a consensus guide at this point, that's better than nothing, because patients are often educating clinicians on what to do.
Maybe I'll just add two quick things. So I think the heterogeneity actually of the phenotype is much greater than evident in the literature at this point. So I think we're sort of still in a phase of data gathering and defining the course of this disease. And the second thing is that in different countries, in different places, there's differences in practice, and plasmapheresis is very much dependent on where you live. In certain countries, Germany, Argentina, they will do it more often. And so how to standardize things and give guidance is difficult. I think at this point we need to describe what's happening, describe the outputs and outcomes, and that I think is already an important step forward.
Yeah, I would agree. I think the thing is that, as Joe mentioned, without the right guidance, sometimes patients are in a situation like surgery. If someone goes for surgery, if they're not given the right guidance, it can have drastic effects. So by not having any of the guidance out there, that causes for concern with patients' overall health. So,
Okay. Any other questions? Yes, Dr. O'Dang.
Sorry, I got too excited by this talk. My other question for you is, have you thought to reach out to other providers that are outside the typical leukodystrophy sphere, the ophthalmologists, even the anesthesiologists, to raise their awareness of Refsum? Because I think we could potentially facilitate diagnosis in anyone that would be at risk at a much earlier time course before you have catastrophic sequelae of disease.
yeah, the ophthalmologist is the one that we're looking to target first, because they're generally the ones that see patients first, right? They generally in their teens, early 20s get diagnosed with retinitis pigmentosa. If the doctor just asked a few more questions, most patients on the registry information, you would see that 70% of the patients have shortened fingers or toes. That's like a visible sign of the disease, right? They could, easily, ask, not that many ophthalmologists ask people to take their shoes and socks off. We might be like looking at them like they're crazy, but, hey, to me, like Dr. Bart Leroy, who's on our medical and scientific advisory board, he always asks all patients to take off their shoes and socks, But yeah, I think educating, we have started also with blindness foundations around the world and educating them, on Refsum and getting Refsum on their websites, and because if 1 in a million is a big, one little tiny needle in a big huge haystack, but if we narrowed it down to the retinitis pigmentosa community, it might be a much smaller haystack, and we could find it's probably maybe 1 in 300 in retinitis pigmentosa community versus 1 in a million in the broader community. So, but absolutely, we're looking. It's just manpower. I need more manpower. I have a full-time job on top of this job, so.
All right. Well, on that note, we're going to applaud our speaker of the last session.